Okay, welcome everyone to the first video of the series of statistics for educational researchers and researchers in general. I've decided to start this new series in English because I think that this will open up the possibilities for everyone to learn about statistics and, more importantly, how we can use statistics for research. Now, the first video will deal with variables and descriptive statistics, which I believe are the foundations for any type of statistical procedure, statistical analysis that you carry out in the future. Okay, so let's start with the first one. Okay, a very important thing we have to consider, and before we actually embark on the journey of, processing and analyzing data, is processing the variables. In order to introduce the file into JASP, we actually need the CSV file, right? You can export it on Excel, and you can do it very, very clearly. Now, important, the variables have to be organized as you can see here. Okay, so in the first group, in the first column, we have the group. That's one of the divisions, and it can be the independent variable. Then we have the sex, which is another variable here in this example. We have the second language, and you see other variables here which are pretty interesting from my perspective. We got writing pre-test, writing post-test, and you can see that each of these columns represent a variable. As I was saying before, it can be independent, dependent, it doesn't matter. But it all has to be organized this way because otherwise, later, it will be much more difficult to, for example, carry out a between subject study or within subject comparison, right? Comparing variables according to the groups. Okay, so let's continue. Once you have the CSV file, which you have exported from Excel, we can continue with the analysis because a new interface will appear. Okay, now a very important thing here, once we have already introduced the file into JASP, this kind of interface will appear. As you can see, we have all the variables which seem to have been categorized. Now, I'd like you to pay attention here, right? I'm going to try to use another more fancy, pointer. Here we got the variables and we see scale variables, ordinal variables, and nominal variables. Now, you see that the terminology used here is slightly different from the one I use here, but they are all in order. For example, a scale is a continuous variable. A continuous variable is like, for example, the time you spend studying or the time you have, the years you've been studying English, that can be a variable. Ordinal variables are, for example, like Likert scale based variables, for example, from a questionnaire. Okay, from a questionnaire. And categorical variables are nominal variables, like, for example, the level of English. We have here A1, A2, A1, A2, or the course, the group you belong to, the participants belong to, the fifth year of primary education, the sex, all these three are categorical variables. And actually, they are not numbers in themselves. But this differentiation is very important because it will determine the type of analysis you're going to be able to carry out in the future. That's why whenever you are doing your research, just make sure that if you want to make comparisons, if you want to compare pre-test and post-test from two different groups, you need a categorical variable because this one is going to act as an independent variable, as for example in the case of group here. Fifth year of primary education and sixth year of primary education, both of them are like two separate groups. And in that case, you can compare both groups, for example, in the case of the writing post-test, for example. Okay, so this is just for you to know, but the types of variables are extremely important. Okay. Okay, very well. Now, you remember very clearly that we were talking about, descriptive statistics, and today descriptive statistics is the topic we're going to be talking about. Now, what can we say about that? That's very important. What is it? What are descriptive statistics in its sense? First thing is, we use descriptive statistics when we want to summarize and describe the characteristics of a specific data set, right? Um, from descriptive statistics, you need to understand that no inferences can be made, or you are not expected to make any inferences at all. So the only data, the only output that we get from this descriptive statistics is, for example, the mean, the median, the standard deviation, but no conclusions can be drawn out of these data, especially because we are not using any other statistical procedures. Of course, we can see that the mean is higher here than in the other group. That's clear. But we cannot draw any conclusions. That's something we gotta have very clear, right? Great. Now, let's continue with the first important statistical procedures, so to say, is extracting the mean out of our data set. What is the mean? That's the first thing we gotta understand. This is very basic because it's not something you see in statistics alone. It's something you've been seeing since you were, for example, at high school or at school. The mean is the very first kind of statistical procedure calculation that we carry out when we are at school. But the mean, what is that? Now, is the average of a set of numbers calculated by adding all the values together and dividing the result by the total number of values. When we want to represent, when we want to show that in our paper, in our research, what we actually do is use that. We use the M and then 240 or whatever it is. Okay. Now, how do we calculate the mean using JASP? Right. This is what we are going to see further. Now, here we got it. Now, the first thing is you gotta go to the module descriptives and click on this descriptive statistics. Now, another tab with a different interface will appear. We got it all here. Now, it's very important that you move one of the variables of interest into the other box, as we do here. It's important that you do so, right? Because otherwise, nothing will appear. You can include all the variables if you want, but for the sake of clarity today in this video, I will just show one or two variables at most, right? Because what we aim here is to show clarity. Now, let's take the first one as an example. In English, that would be study hours per week, right? And once we add it there, we got the output. This is descriptive statistics. Valid is like 150 participants. When you see valid is the number, the sample size that you have. Missing is if there are any missing values. You don't have any missing values here. And then we got the mean here. 10, 11. That's the study hours per week, the mean we get out of all the data set. That's very interesting. A very interesting aspect to include, and I'll show you later where it is, but is the minimum and maximum. The minimum is 1, the maximum is 19. So that means that the person who study per week the most is 19 hours, right? So you see the difference here. Now, this is very interesting here. In the case of the mean, but we have another measure of central tendency, which is, and here we go, the median. What is the median? The median, right, is like the middle value when the data are ordered. So we divide the set into two equal parts. Half of the data points are smaller and the other half are larger than the median. Now, how do we represent that? How do we report the median here? We do it like that. Median 12, for example. Now, extracting this specific statistical calculation in JASP is very simple. The procedure is more or less the same as we did in the case of the mean. Okay, let me show you that. All right, we got central tendency. You will have a tab like statistics, and you can click on the median, right? And this will be the output. I've decided to include the mean as well so that you can see the difference. In that case, the median, which is like the middle number, is not, doesn't differ too much from the mean result. So you can see it's 10.27, which is actually really good. And that's it, right? And the median. Now, you'll surely asking yourself right now, what do we use? Should I use the mean or should I use the median? That's something really interesting, and this is what I'm going to tell you about. Okay, here we go. The mean or the median. Now, the mean is usually more representative of our data set when we have a normal distribution. But if we have a not normal distribution, if the distribution is not normal, like that, right? In which the data is very skewed, positively or negatively, we would prefer the median because it will be more representative. Now, the next question will be, okay, and how do I know whether my data are normally distributed or not? That's pretty simple. As simple as that. I can tell you about that in the following minutes, right? I'll show you the statistical technique that we have to use in order to unveil, so to say, elucidate whether the data are distributed or normally or not. Okay, I'll tell you about that. But first, we gotta finish with descriptive statistics. Now, what can we tell about the other statistical technique? Okay, here we go. We got the mode. The mode is another one that we can use, and is the value or the values that occur most frequently in a data set. It is reported like this, right? Mode equals 5, right? That's the mode. And we can use it whenever we want to see what's the most common number or category. Let me show you that, right? Here, in the same tab, we click on central tendency. And here I've decided to include only the mode. Now, it's important, and I didn't add that here, but I just want to make sure that you got the word in that case, that you get the idea, the hang of it. Now, the mode is generally used whenever we are dealing with a categorical variable. That is, a categorical variable like motivation, right? The variables are discrete, right? Which means that we have a general, categorical or not, but we can use it with variables that are discrete, okay? Motivation is from 1 to 5. So there are no like 2.5 or whatever unless we want to obtain the mean. But in that case, the mode tells us which value is the most common, and the most common is 2, right? Out of these possibilities. All right. Now, with this, we end with the measures of central tendency. Remember, the mean, the median, and the mode. Now, we have other measures that we can use to summarize the data we have out of our data set and regarding our variables. What are those measures? We got, and here we go, we got the measures of dispersion. Now, we will start with the standard deviation, which surely rings a bell because you might have seen that when you were at primary school. So it's a measure, right, of the amount of variation or dispersion in a set of values relative to their mean. I know this is a very statistical definition, like, it will surely be great to you, but it's just precisely, the standard deviation tells us whether our data is very variable or if it's more homogeneous, in the sense that if we have a class with doing a test, right, like a writing test, and we observe, right, whether the variation is very large, that means that we have students with 1 out of 10, 2 out of 10, 10 out of 10, 8 out of 10. So it's very, there is a lot of variability. But if the standard deviation is shorter in comparison to the mean, that means that there is no variation. The variability of the data is too small, right? And that's really important. So the standard deviation, that's how you would represent that, how would you report it, and is associated with the mean. So whenever we are using the mean, you include the standard deviation in order to show how distributed, how variable the data are. And the standard deviation is preferred when, obviously, the data follow a normal distribution. So how do we include that in JASP? That's very simple as well. Okay, here we go. You have to go to the measures of dispersion. And here we got standard deviation. You click on it, right? You tick the box. And this is the output that we get. I've just decided to include the mean and the standard deviation here because we use both of them together. The first thing you got to know here is motivation, okay, 1997. And the standard deviation is 0.81, which means that the the data in that case is not very variable. So it's more or less homogeneous. And in the case of study hours per week, the mean is 10, 11, and the standard deviation is 3, 9, 91. Although it's not a very large standard deviation, this kind of gives us an idea of how variable the data can be. And the data might be a little bit more dispersed, right? As in the case, if we compare it to motivation, for example. Okay, this is in the case of standard deviation. But what happens when, for example, our data is not normally distributed and we want to include a measure of dispersion? In that case, we use the interquartile range, right? IQR, right? That's like the acronym. So what is that? That's the difference between the third and first quartile of a data set, and it actually represents the range within which the central half of the data lies. All right, because of these videos are not just centered on mathematical concepts or an understanding that very mathematically speaking, I just want you to understand that the interquartile range is used along with the median, right? Or when the standard deviation is not very representative of the variability of the data. So we report it like that, and it's associated with the median. And we use it with non-normal distribution. That's something we have to bear in mind. If the data is not normal, median and in interquartile range. Of course, if the mean and the standard deviation are okay, because they are representative, we can keep them. That's something we have to understand as well. So how do we do that in JASP? All right, we click on dispersion measures. You saw them before. We click on IQR, and then we got it here. Like the IQR, as we can see here, is like equal to the median. So it means that there is some variation. And in the case of study hours per week, we can see that the values are more or less very similar to the mean and the standard deviation. So the variability is more or less the same, as similar. The only change is the motivation here. But the problem is that this is out of a Likert-based scale. So sometimes it's preferable if you use the mean and the standard deviation in those cases, right? So this is in the case of the interquartile range. We have a last measure of dispersion, okay? And this last measure of dispersion is the variance. Now, what is the variance? Okay, here you got the definition, and it's like the degree of dispersion of variability in a data set, and it's calculated as the average of squared differences between each data point and the mean of the set. Okay, that's a lot of bit of chit-chatting, and I know this is difficult to understand, but I'm going to help you interpret it. This is how we report it, the variance, and the variance is associated with the mean. So we generally use the mean and the variance. But when? Only when we are using ANOVA, because it allows us to see how dispersed the data is, as well as the standard deviation, right? So how do we interpret it? The smaller the variance, the less variability is going to be. I mean, it's the same as in the case of the standard deviation. So let me show you that. How we do that, how we carry that out in JASP. We have to click on the variance, you see here, okay, and then we got the answer. The variance here is very short, so it kind of coincides with the standard deviation. But in the case of study hours per week, we see that the variance is too high, so maybe there is a problem of variability here, and we have students with very high values, and the data might be a little bit skewed. We're going to see that with the data distribution test, right? Which is the last thing we're going to be seeing in today's video, okay? So this is the variance, but if I were you, I would just stick to what is orthodox, to what is the norm. Mean, standard deviation, median, interquartile range, okay? All right, so let's continue. Now, the last thing we're seeing today is how we check whether our data is distributed or not. Of course, we can use plots, but I prefer to use the statistical procedure because it's easier to see. I wouldn't say that we should trust much more on this test, but it certainly is much better from my perspective. So the Shapiro-Wilk is a statistical test that we use to determine whether a data set comes from a population with a normal distribution. So important, if the p-value is significant, the distribution is not normal. So it helps us decide which type of inferential statistics to use. And we will discuss this, we will comment on that in future um, in future videos, right? In English, of course. So how do we carry that out? I mean, in JASP. So the process is extremely simple, right? You don't even have to change the module. In the descriptive modules, you just have to go to distribution and you gotta click on the Shapiro-Wilk test. This is the test that tells us about its normality or not. Once you click on it, and depending on the variables you've included in the boxes, right, you will have the outcome. So what is this? All right, we got the mean, the standard deviation, and the Shapiro-Wilk. This is like the statistics. And here the p-value. The p-value is what interests us most. If the p-value is significant, that is below 0.05, all right, we can conclude that this specific variable is not normally distributed. And in that case, the motivation is not normally distributed. That's why we were getting so different variation numbers in standard deviation, in the quartile range, and also in the variance. So the p-value here indicates that yes, is not normally distributed. But in the case of study hours per week, if you check the p-value, we say that it is not significant. So it means that the data are normally distributed. Okay, this has a lot of consequences in future inferential statistical procedures, because if the data is not normally distributed, we may opt for a different statistical test. This is important, and mark my words, we're going to talk about that in future videos. So, once again, thank you very much for watching. I sincerely hope that you like this video in English. I had it all in my mind to do it in English, and someone mentioned that around in social networks. So I decided to do it in English, and I hope you like it. So thank you very much. Thanks for watching. If you are not subscribed, just make sure you subscribe to my videos and leave a comment, because I'm open to any suggestions. So thank you very much.